quite interesting because I'm basically going to repeat a lot of what Sumit has just said. So if you were paying attention, you can now have a quick nap. If you were not paying attention, then hopefully you'll see my view on it, and maybe I've got slightly different opinions and approaches. Also, I'm not going to talk about gRPC at all. So my name is Rob Allen. I'm an API consultant. My job is to help my clients do APIs better. So if you've got that sort of problem in your company, please feel free to reach out to me because I would love to help and make APIs better for everyone. Think about APIs in general. They could be realized in any style, practically. We're worrying about which one makes the most sense. Now, as Sumit mentioned, particularly with MQTT and gRPC and real-time stuff, it's a very, very different world. But most of us are not building those sort of applications. Most of us are building general web APIs. So it doesn't particularly matter whether we're using REST, RPC, or GraphQL. They've all got pros and cons. They've all got advantages, they've got disadvantages. There is a balance of features that you will need to pick from. Which one will make the most sense? Short answer, because we're in the software world, is it depends. Depends on what you actually need. So what I'm going to do first is talk through each type of architectural style and then give you some opinions. So we'll start with RPC. The oldest style. RPC APIs have been around forever. RPC stands for Remote Procedural Call, and it literally does what it says on the tin. You are conceptually calling a function on a remote server. Essentially, thinking about it as if you are making a local call, but it takes a bit longer because we're going over a slower communication network. Common implementations, JSON RPC, SOAP, which we don't talk about, gRPC, and tRPC. tRPC is a fairly new one. It's related to TypeScript. If you're in an all TypeScript world, it's really interesting and worth looking at. If you're not in an all TypeScript world, then you can forget about it. Practically, it's of no use to you. I don't live in an all TypeScript world, so I've not really looked at it in much detail. Tends to require a schema. So with JSON RPC, you tend to see OpenRPC. For SOAP, you're going to be using WSDL, and for gRPC, you're going to be using protocol buffer. tRPC, the contract is the TypeScript. So let's look at JSON RPC. You might think this is really old and nobody uses this anymore, and you would be wrong. This is still current and people are still using it, and even in new stuff like blockchain, there are APIs written using JSON RPC. It fitted their requirements. What do you do? Here's a request. We make a post to an endpoint. We pass the payload. We have some boring metadata properties like JSON RPC version 2, ID number 1 for this message, and then you're calling the function. So you've got the method, and then you've got the parameters, and you get back a result. It's literally like calling a function on another server. Dead easy. RESTful APIs. Sumit did a great explanation of RESTful APIs, so let's talk about the really important one. You're operating on a representation of the state of the resource. That's the whole point of the REST bit of RESTful. It's quite a mouthful. Most people don't do it very well either. Most of what we call RESTful APIs are more RPC-like in HTTP clothing to a certain extent. But they are HTTP native, or in particular HTTP 1.1 native, which is a very good thing. That means that we're using HTTP verbs, we're using get, post, put, delete, etc. We're using headers for content formats. It's an extremely extensible format and protocol of HTTP. There's a reason HTTP 1.1 has been in operation for 20-something years and has not changed. That's an amazing accomplishment for a protocol. HTTP 1.1 is amazingly good at what it does. If you're going to do RESTful, you're going to have hypermedia controls. So you're going to have the concept of links for state transitions so that you can help your clients go to the next place, what they need to do next, related resources, things like that. This is the bit that most of us don't do when we write a RESTful API, because it's hard. And we don't like doing hard stuff. Here's a request. We post to an endpoint. This endpoint normally has an actual URL instead of being just a root. So here is /users. That represents a collection of users. I'm making a post request, not a GET request. So I'm creating a user, not retrieving a list of users. Operations are different based on our verb. And then I go send in some data. I'm choosing to send JSON. I could equally have sent XML just by changing the content type. The accept header tells the server the format of the data I'm prepared to get back. So I could have said I will accept XML back, but I'm giving you JSON. And a good RESTful server will handle that appropriately. We have built-in ability to format shift as we need to. It's a very flexible thing, RESTful APIs. And your response comes back. It has a status code. These matter. So 201 is created. Content type tells us the format that we're going to get the data back in. This one is HAL plus JSON, which means that we can expect a list of links in it. In this particular case, we've only got the link to the resource itself. This is a fairly good RESTful API. It doesn't have an ID, you'll notice. The concept of an ID doesn't really exist because this is a representation of the resource on the server. So if you care about that resource, then you should go to the self link, not care about the fact it's ID 1234. That's RESTful. GraphQL APIs. GraphQL APIs. These are slightly different. You retrieve only the data you need on the consumer side. You get, as a consumer, the choice of which particular data fields you want. This can reduce the number of calls that you need to retrieve the data because you can embed resources within your query. It is self-describing. It has a typed schema, which makes it quite easy to work with. So if you've not seen a GraphQL query, it looks something like that. I'm assuming everyone's seen more REST than GraphQL, so let's go through this in slightly more detail. So we have the query. The entire query is wrapped in a query text, and then we are asking for an author. Then the bit in brackets is a filter. So of all the authors in the possible collection, I want the one that's got a name of Anne McCaffrey. And then I'd say which particular fields I want. I want the ID and the name. And then I can do my embedded resource, my embedded data. I would like a list of the books that Anne McCaffrey has written, but I only want the first 5. For those, I would like the total count. The total count is the property on the collection, and then in edge and node are the books themselves. And that's where you start seeing the graph bit come in. So this is a graph query language. So we have edges and nodes and things like that going on. And then we get the result back. It looks something like this. It comes in a data block. There's our author with our rather weird ID. And there's our list of books. It says that there are 6. And then we have the edges with each node in title. And there's Dragonflight is the first book. Total count of 6 is wrong, because Anne McCaffrey has written way more than 6 books, and she's an awesome author, so you should probably read them. They're really good books. Which one do you pick? Which makes the most sense? I don't have particularly strong views. One of the nice things about being a consultant is that I can have the views that are appropriate to make me the most money with my clients. But I do have some opinions, so here are my thoughts on it. But I'm mostly pragmatic about this stuff. 2 supercars, Lamborghini or Ferrari. Which one do you pick? My son has a very strong preference for Lamborghinis. He would far rather drive a Lamborghini than a Ferrari. From a practical point of view, it doesn't really matter which one. They are both very good at going fast, and they are not very good at doing much else. It's totally valid to pick your API architecture based on which one your team is better at and prefers writing. As Sumit said, nobody wants to write a SOAP API in 2024. Literally no one. It might do the job, but you do not want to pick that one. That would be a poor choice, poor preference. How about this one? Lamborghini or some sort of truck? My other son is at university, so every 8 months or so, I have to pack up all this stuff, take it to uni, and then pick it all up and bring it home again. Lamborghini is a terrible choice for taking all of his stuff to the other side of the country. A pickup truck is a much better choice for transporting stuff around the country. If I'm going racing, then maybe the pickup truck is less good. So there are actual fundamental differences between our API architectures that might matter to us. So here are some considerations that we want to look at. What are we going to be using it for? Do we care about response customization? And do we care about HTTP interoperability? They're probably some of the key things that I think you should care about. So, what's it going to be used for? Do you control both the server and the client? If you do, then GraphQL starts looking more interesting. Protobuf and things like that also start looking more interesting as well. If you don't, then REST starts looking better. How many users are expected? Are you going to be getting a lot of users? Is it mostly read, or is it a read and write API, or is it mostly write? That will affect your choices as well. And what is the skill level of your integrators? So if the people that you are targeting to use your API are not bleeding edge developers, they will probably find it easier to write something they are familiar with. And that might have a commercial impact on the usability of your API. GraphQL is a query-first language. It's implicit in the name. So if you need response customization, GraphQL is where it is. Right, you can choose your fields, you can nest your resources, you can pick every field within those nests. It's really, really good at response customization. REST is less good at that. There are some properties and some protocols around enabling you to do filtering of which properties come back in your body, but practically nobody uses them. You might get the big data set or the little data set, and that's about it. With RPC, you tend to get nothing. It's a function call. You call the function, you get the response. It does its work. Efficiently retrieving your data is still key. The fact that you're doing response customization doesn't actually affect the speed that you can get that data to give to your client anyway. So please be aware of that. Particularly when you write on GraphQL 1, it's quite easy in GraphQL to end up with quite complex queries happening. Which brings us to performance. REST and RPC are server-side performance APIs. They concentrate and believe in controlling the performance of the server. GraphQL puts client performance first. It was invented by Facebook for a reason. And one of the reasons was that they wanted to put the control with the client. So GraphQL is really, really good if you want to cede control to the client. That sounds a bit negative, I suppose, but practically that's how it works. GraphQL is client performance. Caching. They can all do caching. You can all cache the application layer because fundamentally you're writing an application. You can cache anywhere inside your application layer. REST can additionally cache at the HTTP layer, which the others can't do because that's built into HTTP. And I've already mentioned HTTP, absolutely wonderful protocol. And caching is one of the reasons why it is so good at what it does. Errors. Error handling. We have to handle errors. I'm going to assume that you have never written a perfect API. There will be errors. RPC, the return payload, will contain some sort of error format if you're lucky. Or it might just not return at all. Or it will return false. REST is HTTP semantics. So you get status code. GraphQL, you're going to get something else. So RESTful errors look like this. You're going to get 503 service unavailable if it's in the server-side error. If it's a client-side error, you're going to get a 4xx error. And then you're going to get a body with some information in it. The information in your body should have human-readable messages, and it should have an error code for computers. And there's a standard for doing it, RFC 9457, which is a new standard from the old standard of RFC 7807. If you don't know how to do errors in RESTful APIs, look up the RFC and do it right. It will save everyone a load of hassle if you can do that. Now, GraphQL errors look like this. Because it's a nested query system and the client is in control, the server will try to return as much data as it reasonably can, and then leave the client to work out what's happened. So in this example, you have an error blob at the top, and it's told me that the character with ID 7 could not be fetched. And then in the path parameter, it tells me where to find that within the actual response data. So it's in element 1 of the friends collection, which is the second one down. And you can see it set the name to null, just here. And then it's a client's problem to work out that an error happened and not do something with that particular record and choose whether they want to display any friends, or maybe they just wipe that particular one friend out of the response that they show to their user. Versioning, you can version all of them via evolution. It's just as easy. Makes no odds. I mean, nobody does versioning very well, let's face it. GraphQL is really, really good for deprecation of specific fields. Because the clients have to ask for the fields, you can tell if a field's not being used. So you can take it out if no one's using it. You can't do that with REST. This stuff is hard. This stuff is always hard. GraphQL, you need to worry about naming, and you need to worry about what can be nested. You have to choose your nesting options. Get it wrong, and you get a very difficult to use API. Loosely, we need to balance the developer experience of the API versus our internal app capabilities. And it is incredibly easy with GraphQL to accidentally DOS yourself, create a denial of service attack on your own server. It's remarkably trivial to do that, which is why complexity exists within the GraphQL world. With REST, you need to balance the data sent versus number of requests. Lots of requests take a lot of time. Too much data in one request is inefficient. We don't really want our clients making too many calls. It does have an easier learning curve because of the uniform interface that RESTful APIs have. It's your choice. Fundamentally, it's about control. GraphQL gives control to the client. RESTful APIs, the control lies with the server. RPC APIs, you're probably not building very many for general web usage. I'm going to leave you one last thought. If you suck at providing a REST API, you will suck at providing a GraphQL API. Arnold Lawrence said that, the API handleman. What he's actually getting at in this quote is that your second attempt to write an API tends to be much better than your first attempt at writing an API. And most people's first attempt at writing an API was a RESTful one. When you write your next API, you will get better at it. Your second API will always be better regardless of which architecture you choose. I like them both. I'm happy to use a good GraphQL API. I'm happy to use a good RESTful API. I would far rather use a great SOAP API than a terrible REST one, though. Thank you.